Bienvenue à cette deuxième session de la journée. On va parler de l'intelligence artificielle explicable, du symbolique, des modèles, donc tous des mots qu'on a entendus déjà hier par presque tous les présentateurs. Donc aujourd'hui, je vous demande de... Sorry, I'm speaking French. You don't wake me up. How many people don't speak French here?
Summer school is supposed to be a good thing.
That level of French isn't different.
It's not different, but still, yeah. Let me start again over. I won't repeat everything because we are polite of mine, but sorry, that was not intentional. So, back to business. Welcome to the second session of this afternoon of our 9th day of the summer school. And we will hear now a presentation given by Florence Dupin de Saint-Cyr, who comes from Toulouse, my city in France, for those who don't know. Le cassoulet is the specialty there. Okay, sorry. So the talk will be about explain about AI and more specifically, but not exactly explain on AI, although this is our label. It will be about formalization of interesting cognitive phenomena. We'll speak about jokes. So it's not a joke anyway. But she will really speak about jokes. I can tell that. I was probably one of the few who survived till the end of the papers that were attached to the presentation. So without any blah blah anymore, what else?
Thank you.
Sure.
First, I would like to thank the organizers for this invitation because it's a very big pleasure to be there, to be here. So he said everything. The main thing in this talk will be to relate belief change and story understanding. Two topics that are completely far away, but I think at the end you will see the link. So I will spend a lot of time on introduction. If you are, I don't know. So I cannot see my my title, but it's about reasoning formalization. But I don't know the title. Field of AI, exactly. I would write it. So, yes, in fact, why do we care for formalizing reasoning? Because it's interesting to produce an ideal reasoning in order to help people to have good reasoning. An ideal reasoning would be called rational, and we will have to define the axioms in order to say if it's a rational thing or if it's not rational. The idea also is to simulate human reasoning in order to better understand it, make its mechanism explicit by encoding it in logic or in a formal way. It is important to predict the conclusion that a human will reach. For if you want to design systems that are dealing with human, it's better to predict what their reasoning will be. And human people would be interested to have some feedback about their reasoning or about the reasoning of their enemies or of their friends. So it's important to be able to repair some bad reasoning or guide some reasoning. So it's important to formalize reasoning. I hope that you are convinced. And then I do this and it doesn't work. I should.
Aside.
Okay, thank you. So how we do it? We have to make explicit the knowledge and the beliefs of people. So, you can start from explicit knowledge that is already there. You have text, you have drawings, diagrams, graphs, logic, math, some representation, some knowledge represented already. But you have also implicit knowledge to take into account. For instance, knowing how to do, knowing how to be, ability to recognize. This is very difficult to represent. So the first thing to do is represent knowledge. Then you have to define inference rules in order to derive knowledge from knowledge. And it depends of your representation language. And then the usual papers that we write, we represent knowledge, we define the inference rules, and then we show that it is accurate with good properties. And then you publish. The properties can be about complexity, computational complexity, but others. So, for instance, you can represent knowledge like this. I know A. I know that A implies B. You can have inference relation. This is the symbol of infer. And modus ponens is the classical one. When you know A and A implies B, then you infer B. And you can have the property that this inference is monotonic. This is a classical inference. It is monotonic. It means that if I add some information of, I cannot derive not B. What I derive with this information, I cannot change my mind. So, in fact, AI has two parts. And it's similar with system 1 and system 2 of Kahneman, you know. I saw that you have had a lot of presentation about it. So if you, the usual, now the popular thing about AI is more, the first one is a data AI, what I call data AI. It's made with statistics, and it uses machine learning and automatic prediction generation. And it's more like a system 1, very fast, but not transparent. And you have the second part of AI, which is often called symbolic AI, but I prefer knowledge AI. Or KR. KR means knowledge, representation, and reasoning. Because the main aim in this domain is to represent the knowledge and to have explicit reasoning. So we come to the slow system of an analytical system like the system S2. And in this area, you can have special reasoning like causal, temporal, spatial, non-monotonic, ontological, reasoning on imperfect knowledge. I didn't put okay. And the new trend, but it's not so new now, is to do the bridge between the two areas and to go towards explainable AI, which will benefit from the two systems. So in the brain, Kahneman says that the two systems were observing each other and guiding themselves. So explainable AI will benefit from the two systems. And I will talk in this presentation about the 3 points in red. So I think you have heard of this pyramid. Normally, at the top, it is wisdom, but I don't want to have a judgment of, so I prefer awareness. So normally, in fact, you have data. Data is the more, the less informative thing, because it is not interpreted. Data is what the collected elements. Then you interpret it and you have information. Information is what does system one. It is what does generative AI and machine learning. So it takes data and it gives you information. If you organize information, you come to knowledge. And knowledge, you have a symbolic and compact representation of the information in order to produce new information or new knowledge from knowledge. And I don't know what you do. Maybe you take a step back, and from knowledge you come to awareness. You are able to produce meta-knowledge. Ah, yes, this is a blank one because belief change is related to intelligence. Why? Because only fools never change their minds. So it means that I should take it in the right order. If you you never change your mind, then you are full. So if you are, if I take the contrapposite, it means that changing mind is clever, is intelligence. So this is why I am interested into belief change, because I do artificial intelligence. A little joke, I'll let you read. So what's the point to be interested in belief change? It's because, in fact, it's very important. Beliefs are very important for our species, because we have to predict, to plan, to explain. And explain means attribute cause. How do we build our beliefs? But it may come from intuition. Intuition comes from experience. So this is system one. And it becomes from reasoning, which comes from other beliefs that we have already built. So we can build causal laws, and by generalizing some behaviors, and we can observe facts. But above all, what makes Homo sapiens the best species, not the best, but the most powerful species on Earth, is that we have common beliefs and social norms, and we share them. And this share of beliefs makes us very powerful, because we can cooperate or we can compete, and we can get organized, and together we make many things more or less good for us, but or for ourselves. And how we do this? How we have common beliefs and social norms? By communication. So in fact, it's a matter of persuasion. You have to persuade other people to believe what you believe in order to come with you. And so persuasion is very important, and so belief change is very important for persuasion. How to do it? So the challenges are in order to formalize reasoning about belief change, it's difficult for several reasons, because human brain has bounded rationality. So sometimes we are not available. Our attention is not at the top. This is a promotion for all my papers. You can read them. Belief change is, bounded rationality is also because we have biases. We use fallacious reasoning on purpose or without knowing. We are sensitive to the form, to the manner that people use to present things. And sometimes when we discuss, there is humor. Candid engagement is also a particularity of human beings. When people listen to stories, they engage to listen to it, and they remove their critical thinking. This is but I will come back to it. We have prejudices, and it is important to deal with all these things. Moreover, we have ways to represent things. We should deal with uncertainties, incompleteness, manage inconsistency, and adapt. If we are in logic, we should adapt material implication because it doesn't work well with some default rules, for instance. And it's not natural in human being, material implication. So there was a broad area of research about reasoning about change. And it starts at the beginning of AI, in fact. And at the beginning of AI, they defined some languages like this, where you represent actions or events. So there was the topic of belief change theory. It started in the 90s. Non-monotonic reasoning was developed at the same moment with divisible reasoning, argumentative reasoning, interactive argumentative dialogue systems, and reasoning about change was the topic of planning, and where you either represent time or not in different systems like linear logic or reified logic, where every formula is indexed by a time point. So this was a very big area of research, and this area is slightly less popular now because of the advent of GenAI, but still there are some lessons to draw from this. So the second topic I wanted to talk about is stories. And in stories, there is an important thing. It is the narrative tension. And why stories are interesting to study is because it is intelligent, because you have to understand the story. Understand means you have to be intelligent. So it's artificial. You can do it with artificial intelligence. And since we say understand the story, we can do machine automatic understanding. But in fact, the more interesting thing in understanding a story is that when you read a story, if you read it well, you will be engaged, and we call it candid engagement. I will come back to candid engagement definition after. But the idea is that when you are reading a story, you forget the real world. You don't think anymore. You are in the story, like if you were the character of the story. So what's the point? When you listen to a story, you have to find the connection between the facts and the events. You have to find the laws of the world that is described to you. And in fact, this discovery makes you candid, because you are going to incorporate the idea of the author of the story about causality. So a story is a simple way to communicate ideas and belief, because you will remember them, because a story is compact, and it's easier to remember when it's compact, and it's easier also to tell to others. So you have a communication effect that is very easy. You have images in the story, even images, mental images. So it can provoke emotions. And when you have emotion, you remember feeling better. And it's deliberately incomplete in order to let you imagine the rest of the story. So you have researchers that have proven that a story is engaging if you have a narrative tension, which creates a commitment to listen to it. The listener engagement enables persuasion. And I can recall that you can distinguish between persuasion and conviction. Persuasion is using emotions, while conviction is using only rationality. So if you listen to a story, it's nice if we can provide you a way to help you to be aware before listening to a story that it will happen something that will change your causal. You can go there and listen. So it's nice if we had tools to explain the mechanism of persuasion and communication objective behind the story. And if we analyze the discourse of the story, we can stimulate critical thinking of the listener. Maybe we can also help to generate discourse, but with cautious. We should be aware of ethical concerns and share the same values as the listener. So, in fact, stories are not very well known, while speech and rhetoric is a very old area of research. For instance, in the first century after Christ, there was an axiomatization of how rhetoric should be done, how you should convince your audience. So you should first figure out what to say, then know how to organize what you are going to say and when, choose how to say it, so the form, know how to combine speech and gesture, and remember what one must say. So 3 axioms. And they were studied in artificial intelligence with natural language processing, argumentation, and in logic. You have works that analyze political discourse and see if they are good in rhetoric, if the speaker is self-contradicting or not, and so on. Concerning narratology, it's the science that study narrative techniques. The AI approach is called computational narration. And there are articles based on linear logic, planning, game theory, serious games. in order to handle storytelling problems. In fact, when you study storytelling, you should choose the event and facts that you are going to say and choose when to say them. And you have a communication goal in mind. For instance, if you want to make the girl very nice and quiet, you would tell them the stories of La Comtesse de Ségur and so on. And each time has their own norms in order to tell story to children. So for instance, let's consider this very small story. Cecilia enters her office. She sees a closed box lying on her desk that was not there when she has left the room. This is the first level, the speech. But in fact, behind this speech, you have a scenario, a complete scenario, where you can represent each time point with the state of the world and in red the event that occurs. There is this was the scenario in the mind. Let us suppose that this was the scenario in the mind of the author of this short story. So this is the third level. The second level is the encoding. In fact, each sentence is encoded by for instance, some formula with the time point. This one is the event that occurs at time point 1. Then there is an event, there are facts that are true in fact in time point 1. At this time, there was a box on the desk of Cecilia, and the content of the box was not visible. This is summarized by not visible. And then we learned that the box was not there in the previous time point. So we can see that the story is not written in the order of the time. So this is why you have 6 levels. And how do speech differ from story? In fact, in speech, you are committed to what is said. So either you agree with what the speaker says or not. In the story, you are more committed to listen until the end, and you are immersed in a fictional world. In the speech side, you can have empathy toward the speaker. In the story, you often forget the speaker, but you have empathy towards the characters. In the speech, you can be sensitive to the form, while in the story, more in the universe of the story. In the speech, you have a communicative objective that is more or less known. You know what the speaker wants to make you believe. In the story, is more or less implicit. And in the speech, you have one level of knowledge about the discourse, what the speaker says, while in the story, not only what the speaker says, but what the characters knows. It's another level of knowledge. So it's good for modal logic for those who work on it. So what I will speak about belief revision and stories, but I won't speak about this data-driven AI, reinforcement learning, deep learning, generative AI, decision support, and multi-agent system. But maybe I will say some words. So before I have finished my introduction. So before continuing, my idea is to present belief change theory because it's a basic fundamental work, and it will be maybe a little complex, but then we will have a gratification. We will have a funny story. Funny, we will see. And then I will speak about narrative tension. So belief change theories. In fact, a belief base is a set of logical formula, let's say. And you have several problems. It can be incomplete. This means that you don't know exactly in which world you are. So there are several possible interpretations. You have a line, A is a line, but B is not, or both are a line, or only or the same, but F of A. But okay, so you have several possible words. This is the case when you don't know everything. You have you can have inconsistency when the knowledge is too complete, because it contains contradicting information, and so you have no information, no interpretation. And the third problem is when you learn a new piece of information, you want to add it to your belief base. And I want to show you that you have two different cases. One is called revision, one is called update, and they were identified by Winslet. So a revision, you have an initial belief about the state of the world. We call it K. Then an information describing a shift in beliefs. So we hear that now alpha is true. We call the new state of belief K prime, and we note this with a circle. It means K revised by alpha. Okay. If we speak of update, it is the same schema, but alpha is of different nature, because alpha is describing not a change of the belief, but a change of the word. If I hear alpha, I know that now the word has evolved in order to satisfy alpha, which is very different, and they put a diamond. But I will come to an example. So suppose that my initial belief state is the following. Either there is an apple in a box or a banana in the box. Apple is A, banana is B. And it's an exclusive OR. So this is my initial belief state. Now I hear that there is no apple in the box. So I revise by not A. So I have this revised by not A. Normally, it means that I was wrong with this possibility. There is only one possibility, banana in the box. Okay. Now, if I do an update, it's not alpha is also not A, but it means that the word has evolved such that there is no apple. So we can say the apple thief has been there. So if there was an apple, it's no more there. And if there was no apple, nothing occurs. But then I have two possibilities after my update, which was not the case with the revision, where I had only one possibility. This is my most awful slide. So if you understand this one, you will have all the speech. The main result in this domain is a representation theorem. A representation theorem is a characterization of an operator. Here it's the revision operator, and you characterize it by some postulate where you put your operator and you say how it should behave. And then you have a relation between the fact that the operator satisfies postulates and the computation of the best models of the world that you will have after revising. So this means the models of the new knowledge, new situation, will be the models of new information. So the models where there is a banana, no, there is no apple, that are preferred with respect to my old belief, where the preference relation should be faithful, but I will come back to it. And what is interesting is that you can characterize your operator with some very simple things. Success says if you learn alpha, alpha should be true. If alpha is consistent with what you had before, then you have only to add it, and so on. So these are some postulates. And we can see it with a new example. So you see there that in order to make a revision, I need this pre-order, a pre-order that is based on my initial knowledge. So here, suppose that my initial knowledge has this pre-order. So because my initial knowledge is that I have a fruit that is round or long and is green. So in my initial knowledge, this is the preferred word. But then I have an avocado, and then I have vegetables that are green, and so on. But they are less and less plausible with what I know. Now, suppose that I hear that, no, what you knew was not exact because it is a vegetable that you have. Okay. What is my new belief? I will take the closest word from my initial knowledge that satisfy vegetable. So guess what I will get? No, avocado, we consider that it is a fruit.
Fruit, it's a fruit.
So what, maybe salad, no? Cucumber, in fact. Because it is the closest word where it is a vegetable, closer from what I know. And salad was after.
Obviously, I don't feel the same role.
But it depends what you define as a vegetable. So yes, this is revision.
To devise my beliefs.
Yes. And this is this was to explain if you have the interpretation of your knowledge base, then you revise by alpha. You take among the model of alpha those that are closest from your initial knowledge. And if you revise by beta, you take from the model of beta those that are most close from your initial knowledge. Okay, but for update, we have the same representation theorem. But this time, you remember that when I update by not apple, I had two words. Each word has evolved. This is the same in the representation theorem. For each initial word, we should make a distance to this word. So the models of the knowledge base that is updated by alpha is the models of alpha that are close to each, is the union of the models of alpha that are close to each word of the initial knowledge. But and you have some postulates that are slightly different. But let's try with an example. So suppose that I have the same initial knowledge, I have a fruit that is round or long and green. So this. And I learned that now it is only scraps. Okay, so it's something like that. So I should take for each possible initial word the closest. Maybe there are several closest words, but all the closest words that are scraps. So for the apple, I will take this, and for the banana, I will take this. It will give me this. So if I update my initial knowledge by scraps, I will get a core, apple core, and a banana peel. This is a little different, but you need to have a pre-order for each word. So this was the difference between belief revision and update. And in fact, there is another kind of reasoning that is called non-monotonic reasoning. And non-monotonic reasoning is a system where you don't want monotonicity. Monotonicity is in classical logic. The classical inference is monotonic because if you can derive from phi psi, then if you add alpha, phi and alpha also gives you psi. There was a system called system P for preferential, and which is defined by axioms about what you can do with an inference relation. This is written like this because it's no more monotonic. So it's not horizontal. You have like this. But it's a non-monotonic inference relation. These are the property of this inference relation. You can add a rational monotony saying that you have the right to derive the same thing as you derived before if alpha doesn't is not against the negation of is not against beta. So alpha is not a typical not beta. Then you can add beta and derive gamma as before. So it's a weaker monotony than the classical monotony. But what I wanted to know to say is that you have a representation theorem that says that if you define a non-monotonic inference relator or inference operator, it's equivalent to define a plausibility ranking on words. Hence, in fact, non-monotonicity and belief revision are the same amounts to have ranking on words. So that's all about theoretical things, but it will be useful for iconic stories. So we have finished with the very difficult part, or not. So let's see the funny story. Sorry if it's not funny. A man has just been hit by a car. So the driver gets out of the car and says, "You're in luck. We are right in front of the doctor's office." So that's not funny yet, but you can laugh now because it can be called a joke with several steps. And the punchline is after, great, except that I'm very funny. So it's not from me, so it's from a collection of funny stories, so-called like this. So we tried to modelize why a story is funny or not. So and we argue that listening to a story is a kind of belief revision. Sorry, a listener is characterized by his knowledge, but also his way to revise her belief, because he needs a ranking of the word. How he ranks the word given his knowledge is sorry, thank you. Listener is characterized by so his knowledge and his way to revise. So he is characterized by a ranking. Which has K as a parameter. So I recall that revising K by phi amounts to compute the closest word for this preorder that satisfies phi. And we will define a simple story as only a pair. Alpha is the context and beta is a punchline. For instance, the stories that we have seen, we can say that we have a man that is injured, and we know that the doctor is nearby. And the punchline, we have the man that is injured, but it is the doctor himself. And we can have a knowledge base like this, with strange arrows that are default rules. Yes, it says that if by default, if you're injured and there is a doctor nearby, then you will be treated rapidly. However, if you injured and there is no treating doctor, then you won't be treated rapidly. If you doctor himself, then you have a doctor nearby. But if the doctor himself is injured, then there is no treating doctor. So this is the rules. But we can say that in this story, beta is surprising because we can deduce from the revision with alpha, we can deduce something that is contradictory with the revision with all the story, alpha and beta. So from this knowledge base and this information, with alpha, I deduce that the doctor will be treated rapidly, but the man. And then with this, I deduce that he won't be treated rapidly. So first, I thought he was treated rapidly, and I am surprised because when I know all the story, there is a contradiction. Therefore, the story is surprising. We can have also the property that a story should have a revealing punchline, which means that if I have known before the context that beta was true, then I would have understood it perfectly. So it is revealing if when I know beta, I can deduce the context. For instance, when I know that the doctor himself is injured, then I can infer that it is injured and nearby. And the third ingredient, no, this is to say that a potentially funny story should be surprising and revealing. And we have made some proposition because some property. For instance, you should not reveal the punchline before the end. It won't be potentially funny. And we have made some properties. The shortest jokes are best. When you are psychorigid, you cannot find a story potentially funny, and so on. The last ingredient is incongruity. Incongruity is a very special ingredient. It is linked to the violation of a social norm or a norm. So, for instance, it is incongruous to drink water from the finger racing basin or to wear shoes that are too big, like clowns. And so it is deliberately disregarding, when you deliberately disregard an obvious universal law, you are incongruous. For instance, the riddle of the 4 elephants, you know it? It is a French one because you use this. So how do you fit 4 elephants into this car? You know it.
In the front.
Exactly.
Yeah.
And this is this is a very good example of incongruity because you obviously deny the law that elephants are huge. So we can prove that incongruity is to when the story is incongruous if there is a norm that is violated by your story. And when ignoring this norm, the conclusion is completely logical. So we have encoded this example, and we can prove that the story is incongruous. Okay, narrative tension. I will go 5 minutes, so I have time. In fact, narrative tension has been characterized by 3 emotions that are crucial if you want to engage people to listen to a story. So you have to manage to build suspense, surprise, and curiosity. Surprise, we already have done it in the previous part. Suspense is when you feel that a dramatic event will occur in the future and you don't know. And curiosity is that some crucial information is omitted and you want to know it. You can have other emotional mechanisms, but we were not able to encode them. Let's come back to the story about Cecilia. You remember Cecilia walks into her office. She sees a closed box on the table. And we argue that this story can create curiosity, suspense, and surprise. Why? In order to encode it, we model things. We have facts. So we model the belief state of Cecilia. Oh, okay. So, maybe, yes, I think. So what she knows is that there was no box at time 0, a box at time 1, and the content was not visible at time 1. And we think that she has some strict rules that allows her to reason. For instance, she knows that if the box is there at t+1 but not there at t, it's because either Albert or Erwin has placed a closed box on the text. If the box was not visible at t but visible at t+1, it means that Cecilia opened the box at t. And we have default rules that allows us to build a ranking on models. The more specific rules are in the highest strata. You can use a system in order to automatically stratify your rules. The more general rules are persistence laws. When a box is there, it is there after, but it has exception. This one. When there is no box after. It has exception. If someone puts a box, there is a box. So this one has this exception, and so on. This one, when something is not visible and Cecilia opens it, it becomes visible. Unless it is empty, then it is still not visible. So you have this kind of stratification, which gives you an ordering on the models, and which allows you to define a revision operator. So in order to model this kind of thing, you should define awareness. You are aware of a variable if it's in the fact or if it's in the rules that concern the facts that you know. For instance, in this story, the listener is aware of box and visible, and therefore it is aware of these variables. And so when it is aware, it can deduce some things. The curiosity, you are curious about something if you are aware, but you cannot derive it. And in our story, the listener may be curious about who placed the box, Albert or not Albert. And the listener may be curious about the contents of the box. Is it empty or not? Because it is the listener is aware of these variables. You can feel suspense if you are curious, aware of a formula, and you are not able to infer it at a time after. For instance, at time 1, the listener feels suspense about whether they will find out if the box is empty or not, because we don't know. There are several possibilities. And in fact, we can use also the importance of events. And there is a work that was done by Trabasso and Sperry to evaluate the importance of events. They draw a graph with all the events of the story. And when an event has some consequences, they draw several arrows. And the more an event has arrows that comes in or out, the more this event is important. For instance, 62 is very important. If you remove it, if you don't know if this event occurs, you will be more curious or there will be more suspense. So this could be taken into account in order to make a graduation. And you could also use something like this for suspense. You feel suspense, the suspense degree of the formula could follow this pattern. You first don't know. At T0, you are aware of phi and you are curious. Then your curiosity is increasing. Then it reaches a plateau. And after a while, you forget. So you no more feel suspense unless there is a recall about the variable that you don't know. Conclusion, sorry if I was very long. Conclusion. All theoretical tools from the 90s are very useful if you want to model change in beliefs. So I recall I present revision, update. I hadn't the time to speak about extrapolation, so I won't detail. Non-monotonicity is also interesting because with non-monotonicity, you can use default rules, and default rules are very useful, for instance, for describing persistency, because persistency of the facts is diffusible. If, for instance, there was a visible, not visible at time t, implies not visible at time t plus 1. It has exceptions when someone makes an action. There is a I describe also ingredient to understanding a joke or a story. So surprise and revelation can be translated into properties about a revision operator. Incongruity is defined by a violation of a norm plus reasoning by ignoring it. Curiosity is defined by incompleteness but awareness, so a desire. You could add the desire to know, but we didn't do that. Suspense is the possibility of knowing later, but we could add some emotions with that. So these ingredients like this can all be gradual. And many ingredients remain to be formalized, like the superiority is a property of jokes. Sometimes authors about analysis of humor say that superiority is an important ingredient because there is a feeling of superiority when you understand a joke because you become part of the team that are on the good side of the joke. For instance, if you make joke about mathematicians or physicians or biologists or other kind of people. Okay. Yes, there is a link between causality and narration because narration stories are ways to send you causal laws, but I won't go into detail. This is some work about causality in argumentation, but I won't go into detail. Because there is a link between counterfactual and causality. Causality, A cause B. If I hadn't do A, B wouldn't have occurred. And if you can translate it into updating the word with not doing A, the action A. Bref, this is causality is related to update. Yes, so in perspective, we could go towards ethical persuasion, but in that case, we should be aware of the values of the people to which we are addressing. And this, okay, this requires analysis. And this work was part of a project that we have that is financed by Defense of France. And it's the aim is to empower citizens against influence campaigns, because influence campaigns can be viewed as stories. And in these stories, we want to know what is the communicative intention of the people that make the campaign. I think that's all.
So we got the time to ask questions. Online also.
Thank you for
Okay, so first question here.
Yes, well, last week I gave a lecture in the summer school about causal reasoning with the major premise of it is a conditional, and I related that to the abductive structure of reasoning, and I'm now much interested in reasoning in which the major premise is counterfactual. And at the end of your talk, you open the door. I would like to have your standpoint on this. How do you relate counterfactual reasoning to causal reasoning? Do you have any ideas about that? I mean, how do counterfactuals play a role in causal reasoning?
But in fact, there is a trend of research in causality that takes counterfactual as the premise for causality. So A causes B if the fact that if A implies B, but if I hadn't had A,
Yeah.
then I wouldn't have B.
Right.
So you have to do a counterfactual reasoning. So you have to imagine the world without A. And in this world without A, you should see if you deduce B in order to see that A was necessary to B. You follow?
Yes.
And in order to do this imagination,
Uh-huh.
it's a kind of update because you should change the word such that it satisfies not A. So this is the link between counterfactual and update, but the link between counterfactual and causality is that you can say A cause B because the without A, you shouldn't have B.
Yeah, so I presume that your standpoint is close to the one of, I don't know if you know the book of Ruth Byrne, who was here 2 weeks ago. Her book about the rational imagination, according to which counterfactual could be a trigger to for the development of causal reasoning and for the identification of causes.
But it was said before, Levis' work in 60s. It's an old thing, counterfactuality and causality.
Yeah,
But it has been
I would say improved by Ruth Byrne, for example.
okay, yes.
Okay, thank you.
So maybe I have no answer for you.
Okay.
Because now there is another framework. You know Alpern and Pearl framework, but it was very so with contingent variables. But there is a new one called NES.
Oh, yes.
The necessary set of sufficient sufficient cause. This is one is more appealing for the moment.
Yeah, I would say so too. Okay.
But yeah, this is my.
Are there other questions from the audience?
Yeah, I've got a kind of basic question, really. So what are you trying to do? Are you trying to predict when something is going to be funny? Or are you trying to explain why certain things are funny? Or a mixture of both?
For the moment, more to explain. In fact, I would say I want to characterize what is funny.
Yeah.
So I took the theory from people that are studying humor. They say it should be surprising for a joke with a punchline. It should be surprising, revealing, and incongruous. So I tried to encode these three things.
But this is a classification problem.
Yes.
And I wonder if it is capable of empirical testing.
We are doing it.
You actually got a corpus in your.
In fact, we are doing we are putting all our examples in a data set, and then we encode surprise, incongruity, and revealing, and then we combine all possible things to do an alpha and a beta, but we have no result yet because a master student is working. But maybe from all our data set of strange stories, we will find new stories that are satisfying our three axioms. Maybe they won't be so funny. So it would mean that we need other ingredients.
And you're not yet in prediction.
If prediction is very check if it satisfies my three axioms. I am yet, but I don't know if it's sufficient.
Models basically explanatory.
Yes.
Yeah.
I think that's clear.
But it's interesting to have this model because we can now, when we listen to a story, we can say, yes, okay, it's surprising. Okay, it's incongruous because it violates this law. We can understand better why we find it fun.
I think I would worry when you're compiling your data set. When you judge the various criteria, the surprisingness, belief revision, or whatever.
Yeah.
The worry is that you would have in mind whether it's funny or not as you compile the data set. And there's a sort of data leakage problem, right? In the yeah.
Yes.
I'm worried about separating the.
In fact, we are going to put all the rules that we use in our story in a database. And then all the facts that were used in the story could be mixed. And we will see if we can have stories corresponding to the common knowledge we put. But this common knowledge may be biased for sure. Because it's the common knowledge, it's the laws that we used for our stories.
Okay.
But there are other way to find common knowledge laws, and we could extend. But the aim is not to do a perfect data set. The aim is to check if it is possible to generate jokes
Right.
from a data set logically.
So you want to actually generate new jokes automatically?
It's our current work. Yeah.
That's a different kind of evaluation.
Yes,
Yeah.
it's more long term.
Just ask ChatGPT.
Yeah,
Do that for you to check. Check. I just asked ChatGPT.
We can compare. Do you find it funny? We can ask to ChatGPT.
ChatGPT.
But yes.
But it's not XAI joking.
No, it's.
It won't be able to explain
Exactly.
why. But we can give it the definition of curiosity.
Unexplanatory joker.
Yeah.
Exactly.
Do you want me to tell a joke I asked ChatGPT for improvisation? So an AI researcher asked an AI assistant, so general AI, can you explain me why your answer is false? Okay, but what do you want actually? Tell me, do you want a short explanation, a detailed explanation, or a convincing explanation? And the researcher answers, no, I want the real one. And in this case, you have to ask a human. Is this funny?
Yeah.
I don't think so.
Surprising.
But it's true.
It's surprising, but that's all.
It's not.
No incongruity.
Yeah.
No incongruous. That's what I thought.
Hmm.
It's missing a key ingredient.
Yes.
Exactly. Yeah.
So forget about ChatGPT.
You have questions for the chat?
Okay, so there are some questions in the chat, and then we can come back to the audience.
To the fans. Okay.
Can you read? Okay.
The first question. Regarding past sentence, humans show evidence pretty often for lingering misinterpretation. In example, echoes of the wrong initial parse. It seems like a similar trajectory underlies the belief revision, non-monotonic reasoning of a joke. So in parallel, the people often show evidence of an initial assumption that are violated by the punchline of the joke. No. It's the first question.
But what is garden past sentences?
Oh, that's like the horse raced past the bar and fell.
The
The
horse.
horse raced past the bar and fell.
The
Right. So it's difficult to parse. Because
Avec chemin de jardin.
the horse which was raced past the bar and fell.
Okay.
So the horse.
So you misinterpret. You can misinterpret.
You parse it incorrectly.
So in order to have a joke, you should have the possibility to badly interpret to interpret it normally, the context, and to assume a conclusion from this context. So you should have the possibility, several possibility of interpretation with a preferred one, in order to be surprised, and then to understand that it is possible. So this is why when you are psychorigid, you have only one interpretation, and you cannot understand the joke because you never think possible another interpretation. So I don't know if it's the answer. Maybe yes.
Perfect. And the second question from Julia again. She asks herself why aren't garden path sentence also funny? What is the difference between resolved confusion and funniness?
But it's funny. Yeah, non-farce. It's not funny.
Past the barn film, it's interesting.
No, it's not funny.
En gros, en fait, elle se demande la différence entre...
I think it's incongruity. When you have no incongruity, you miss an ingredient. You have, because you have several cases when you have surprise and revealing. So you know how to parse the garden path, but you don't have any incongruities that. So, for instance, when you have a newspaper that say this politician has stolen money, it's surprising. But if you knew it before, it would be logical. So it's revealing and surprising, but it's not funny because you need incongruity. If he has stolen by doing something very sexual or something, it would be funny.
Which is the case with the horse. The problem with the horse is dust is uneasy to understand.
So you have a relief when you have understanding, but you don't have the congruity ingredient. So this is why. Okay, I've been working on modeling and updating political beliefs. Against that analysis to me.
The last question, I've been working on modeling updating political beliefs, specifically the tendency to resist updating such beliefs using plausibility models and dynamic epistemic logic. After seeing your presentation, perhaps the vision is more accurate than updating. What would you consider to be specific challenges in modeling updating with those particular kinds of beliefs? What factor do you think we should consider when modeling the kinds of influence people make when receiving new information pertaining to a political belief they hold?
So it is, for me, it is revision, because you don't change the world, you change your beliefs. But maybe if the political beliefs are strategical beliefs, then they are speaking of the future. But you don't modify the world by a new proposal. Normally, you only modify the belief about the world. So it is clearly for me a revision. But those particular kinds of beliefs are beliefs with temporal data. So it's a revision of sequences of actions. So it's a revision of scenarios. So this is the particularity, but you can do it. We did it with extrapolation.
So,
Okay.
okay, other questions from the audience?
Okay.
2 weeks ago, we had a talk about changing our beliefs, the beliefs of conspiracy believers using AI, but it was with serious facts. I guess at the moment, some disinformation campaigns online are using like short form, funny content to change our beliefs. Maybe more, there's like a pro or anti X insert country content. And my question is, how effective do you think they are? And how would you counter it as a country or?
Yes, this is exactly the topic of the project on which we are demain. In fact, we think that stories are the best way to convince people to manipulate, because when you observe a fact, you're exterior of a fact, but when you listen to a story, you are in the character. So you are more involved, more engaged. It is proven by psychologists. And so if you, so this is my first point. I think stories are very good to convince you because you are more engaged. And second, if you use jokes, you make people feel emotions. They release their since they laugh, they release that their critical thinking, and their attention goes away to other things, and you can put information in their brain more easily, and they will remind it easily. They will transmit it easily. So it's very efficient.
Yeah.
That the speeches be more convincing than the stories?
I think no, but because the speeches are not are more explicit on the fact, on the goal, and they don't speak to your emotions. You are less involved. You may be convinced but not persuaded.
Donald Trump uses what he called jokes to talk about wokes, for example.
Yeah, it works very well.
Yeah, and it works well.
Yes.
Definitely a bad story is less convincing than a good speech. So it depends how good it's, yeah, and
It
it's.
will convince you of another thing that you didn't intend. If you make it bad. Yeah.
Another question?
Another question? If not, let's thank the Florence for the nice talk and